We are going to continue our discussion with centroids, but this time use composite bodies. Okay, equations for composite bodies are area is equal to the sum of the area. X bar is equal to the sum of each individual area and the location of its centroid in the x direction over the sum of the areas. And then y bar will be similar with areas and their y component all over the total area. All right, our first example is going to be in millimeters. And we have the origin here. 1, 2, 3, 4, 5, 6, 7, 70, 1, 2, and 30. Be our major hit points. 1, 2, 3, 4. And 30. Okay, my area that I'm going to draw in blue is going to go from 40 to 30, over here to 70. Oh, swing and a miss. Let's try that again. There we go. And I'm going to put a hole in it. 3 at 50. Continue to draw awesomely, ladies and gentlemen. So it's lined up at 50 and 30 here. So let me color in my solid area. Okay. Important information is the radius for this hole is not 0.5, I apologize, 5 millimeters. Alrighty then, tidy everything up because I'm crazy. All right, I wish to find the coordinates of the centroid. Okay, I'm going to break this up into 3 areas. So I'll have my triangular area. I shall name you area number 1. I'm going to have my rectangular area. So both of these are my positive areas. Area number 2. And then I will have my negative area here. Do I need to pick a fun color? Area number 3. Okay, so there are my 3 areas. So the sum of my areas will be area number 1. So it's a triangle, so that is 1/2 base times height plus my rectangular area base. So 30 to 70 is 40. And height is also 40. Okay. And then I need to subtract my whole negative area, which is pi times r5 squared. By the way, this is all in millimeters. I'm being lazy and not writing my units. So my total area here is 212.15 millimeters squared. I hope. Should I check this? 1 divided by 2 times 30 times 40 plus 40 squared minus pi times 5 squared. Oh, I was off a decimal. Come on, eraser. Thank you. 0.5. Thought that looked a little small. Okay, next up is I need each area and its horizontal ordinate. Okay, so for my triangle here, I kind of put my 1 where my centroid lies, okay? And that is 2/3 from the skinny end. So I would call this over here and this down here my skinny end. Okay, and then my red area, it's a rectangle, so it'll be in the middle, as will my circle in the middle here, which, hey, I've already been given that centroid, so that's nice. Okay, so first area is the actual area, which is 1/2 base times height, and then times the distance to its centroid, which is going to be 2/3 of the horizontal distance, 30. Okay, so this right here is my A1. This right here is my X bar 1. All right, moving on to the next area, 40 by 40. And then its centroid is going to be at 30 plus 40 divided by 2. All right, now I wrote that kind of odd. I didn't mean to do that to cause confusion. I'm just measuring everything from the origin. So we have to go this 30 first and then the additional 20 to get to the centroid, which I sort of drew this to scale, and I've got my finger quotes up in the air. You could have just written down 50. Either way, we still have the same X bar 2. All right, last up will be my subtracted area. So we're going to have minus pi times r squared. Okay, and then its ordinate is at 50. Because the math to do that's a real annoyance, especially when it's drawn out the way it is. So that's A3, and this is X bar 3. All right, so that gives us the sum of AI X bar I as $88,073-ish millimeters cubed. So that my X bar, we can now calculate that, is going to be that 88,073 millimeters cubed divided by 2,121.5 millimeters squared. And I'm going to double check my math by typing this out. 88,073 divided by 2,121.5. And we get 41.5. 41.5 millimeters. That seems reasonable. It should be between 0 and 70 millimeters horizontally. And it looks like it should be, you know, past the 30, which it is. So, or past the 35, if you want to go halfway, it should be more to the right from halfway, because that seems to be where all the weight is. Okay. Fantastic. So let's do the same thing for Y. We already have the area, so all I need is the sum of AI Y bar I, and that's equal to, and I said this in the integral lecture, but I remind you in the Centroid by Composite Bodies lecture, this is the same thing that we were doing for our resultant force and distributed loads for simple geometric shapes. Just now we're adding the vertical component to the centroid as well as using the horizontal component. So that's all the change that's on here. Same thought process. Okay, same area. And again, I'm just writing it all out because why not? Times 40. So here is my area, doesn't change, but I'm looking for the vertical distance. So again, I'm moving from the skinny end, so that is going to be 2/3 of 40, because my height is 40 in this case. Y bar, not I, these are all ones. This is the first area. 1 and 1. Okay, plus my rectangle, 40 times 40. Okay, now this time my rectangle is on the x-axis, so I only need to go half of 40 up. 2 times 40 divided by 2. Okay, where my x, I had to move the length of the triangle first and then go to the distance of the rectangle from the origin. This case, I don't have to do that. Y bar 2. Okay, and then again, I'm going to subtract my circular area, minus pi times 5 squared times, and it's at 30, isn't it? Yes. 30. So this is area 3, and this is Y bar 3. Beautiful. So we end up with an answer, sum of AI Y bar I equal to 45,644 millimeters cubed, which means my Y bar is 45,644 millimeters cubed all over my area, 2,121.5 millimeters squared, which gives me a value of 21.5 millimeters. And again, that makes sense because it should be between 0 and 40. It needs to be actually, within the area, and then just over halfway. That makes sense visually to me. So that means my centroid is at 41.5, 21.5 millimeters in 3 significant digits.